Ni hao, good morning, good afternoon, good evening. My name is Robin Malik. I'm the director of Goethe Institut China. I'm very happy to welcome you to Living in a Quantum State, a series of hybrid events in Berlin, Dublin, London, San Francisco, and Beijing. Living in a quantum state is engaging audiences around the world in debates and asking important ethical and ecological questions about quantum computing. Most importantly, this initiative is exploring the role of civil society in regulating emerging technologies and examining how the arts may help us to communicate and understand these major scientific advances. Today's event is focusing on quantum nature, holism, and the space between. The quantum interplay of chaos and order in nature and its role in a holistic interpretation of nature. I would like to thank our fabulous resource persons, Cristiane Morais Smith, Xiaodong, and Liu Yue for their upcoming illumination, and all our Goethe Institute colleagues in London, Berlin, Dublin, San Francisco, and certainly in Beijing. Now we'll pass the digital microphone to curator and moderator Lucy Rose Sollitt. Lucy is a trained continental philosopher and a fellow of the Core Leadership Program, and she has worked for institutions such as Arts Council England and Tate Modern. Her favorite work is to map the contours of emerging art, especially the intersection of art and technology and possibilities for new artistic economies. Lucy, the floor is yours.
Thank you very much, Robin. And I'm really delighted to be here and to have the opportunity to have this conversation. So thank you to the Goethe Institute for enabling it and making it happen. And thank you to our panelists, and thank you to the audience for joining us. And yes, good morning for those in London, good afternoon, anyone in Europe, and good evening to our Chinese audience. And I've been working with the Goethe Institute to curate a small series of conversations, exploring quantum thinking, as Robin touched on. Our previous event was in London, and that was called Dreaming Quantum Futures. And the next one after this will be in San Francisco, and that's with Karen Barad and Rashida Phillips of Black Quantum Futurism. So today, as Robin mentioned, we're exploring quantum nature, holism, and the space between. And we're going to do that through combining insights from quantum physics with traditional Chinese epistemology. And we'll be particularly looking at the complex dynamics of chaos and order in nature, and how the spaces between these states could help support a more holistic understanding of nature, and included within that our own consciousness. And we'll be doing that through the lens of cutting-edge research into quantum fractals, Daoist belief systems, uncertainty, and the process of art making as well. And each of our speakers today is going to introduce us to some of their work and speak about their ideas in relation to this topic. And this is going to take up around about the first hour of the event. And then after that, I've got some questions to draw out some of the kind of connections to the topic. And then we're going to open out the conversations to you, the audience, as well. So please do add any questions that you might have in the chat or the Q&A box here on Zoom or via WeChat. And we'll be collating those, and I'll bring those into the conversation towards the end of the event. So we have around about an hour and 45 minutes to 2 hours. We've started a little bit late, but hopefully we can claw some back some time. So without further ado, I'm just going to really briefly introduce our amazing panelists. I'm going to keep it super brief because you can look up loads more about them on the website. But we have Professor Cristiane Morais Smith, who is a world-renowned researcher working on strongly correlated systems. And she's a quantum theorist who's won numerous awards, particularly in recent years, for her research, and she'll be kind of telling you all about that. And Cristiane is joining us from her country of origin, which is Brazil. And then we have Xiaodong, who is joining us from Beijing, where she lives. And Xiaodong is a curator, artist, and founder of Space Station Gallery. She's also a lecturer of the Chinese Academy of Art in Hangzhou, and She lectures and curates exhibitions around the world and is prolific with her writing as well. So a great honor to have her here. And last but not least, Liu Yue is an artist whose work often takes objective things as a starting point and looks at them in terms of our cognitive experience, and particularly exploring things like the unknown and uncertainty. And Yue has been nominated for several awards, and his work has been shown prolifically around China as well in numerous exhibitions, and we'll get a little sense of some of his work today. And Yue was born in and currently lives in Shanghai, and he is joining us from there. So once again, thank you to you all. I really hope you're going to enjoy this conversation. For me, ultimately, what this topic is about is kind of beauty and wonder, and how we kind of connect to and make sense of the mystery of the nature that encompasses us. And, thinking about some of these ideas from these different perspectives that the panelists are giving, I think is really exciting and gives me goosebumps. So I'm very, very happy to be here and to hear what everyone's got to say. So without further ado, I'm going to hand over to Cristiane, who is going to begin her presentation, which is going to introduce us to quantum physics, and in particular quantum fractals and their possible role in our consciousness. And we're going to be doing a bit of a double act. I will be clicking through Cristiane's presentation as she speaks, so bear with me on that one. Okay, over to you, Cristiane.
Thank you very much, Lucy. It's a great pleasure to be here with you. Maybe you could start presenting, sharing the screen. Yes. So the title is quite provocative. Can consciousness be explained by quantum physics? As Lucy told you, my name is Cristiane Morais Smith, and I come from Utrecht University, where I am a professor in quantum physics in the Netherlands. Next slide, please. So we will try today to understand quantum physics with the help of art. Next. So many years ago, Willem de Kooning, who is a Dutch-American abstract expressionist, told us that every so often, a painter has to destroy painting. Cézanne did it, Picasso did it with Cubism, and then Pollock did it. There could be new paintings again. So destructions are intrinsically connected to the creation of something new. Next. I will start explaining a little bit of the concepts of quantum mechanics. So quantum mechanics is a theory that was developed in the beginning of 1900, and it came to revolutionize our understanding of particles and waves. So until then, we knew two different things. One is a particle, like a ping pong ball. It's something that's localized in space. And something very different is a wave. When I throw a stone in the sea, it makes a wave. And this is something which is spread on a long region. These two concepts were completely different. Because if I put a screen and I throw with two holes and I throw a ping pong ball, the ping pong ball will go through one hole or the other hole. But if I put a screen with two holes and I send a wave, the wave goes through the two holes at the same time. So those were very different things. But suddenly, in quantum mechanics, we learned that every little particle is a particle, but it is also a wave. And everything that we thought were waves, like light, we discovered it is also particles. So this duality, electron, a particle wave, was something very strange that appeared in quantum mechanics. Next slide, please. And this duality is very well represented by the work of Picasso. the previous painters, many centuries ago, they were just portraying reality seen by the perspective of the painter. And they were trying to represent an image in a very faithful manner. But then, at that period, in the 1900s, we already had cameras to take photos. So the function of the artist is no longer to portray reality in a very precise manner, but to bring us something else, something conceptually new. And what Picasso brought us when he does these paintings, where he is representing Dora from the front, from the side, all in the same painting, he tries to tell us, remember, every reality has several perspectives which are superposed, and it's the combination of all of them that's making Dora. Dora is never me looking at her from one single perspective. And that's the basis of quantum mechanics. So, next slide, please. The easiest way to understand quantum mechanics probably is when I throw a coin in the air. As long as the coin is in the air, it is at the same time face and tail. When I put my hand and the coin came on my hand, it will be only face or only tail. But as long as it's in the air, it is both at the same time. Next, please. So are quantum states. This, what you are seeing here now, are the sculptures of a German artist who is a physicist and also at the same time an artist, and he tries to represent quantum into sculptures. And Andrea Fuss, what he's doing as we move around, these sculptures are going from being solid into being transparent, ethereal. This is what he's trying to remind us of, this duality in quantum mechanics. Next, please. The next one that is very important to exemplify what we are going to talk about today is the painter Jackson Pollock. So Pollock changed a lot art. First of all, before the painters were working with the canvas in the vertical, and he has put them on the floor, and he started dripping colors and dancing on top of his paintings while putting one color with one density and another. So it was a very revolutionary way to paint. But there is something else, because intuitively, he was constructing something that are called fractals. Next. So maybe you have never heard this word, fractals. What are fractals? Maybe you have never heard the word, but they are all around us. So here are two examples of fractals. The first one on the left is the structure of snow. If you take a flake of snow and you would look at it in the microscope, it would have this shape, which is called the Koch curve. You can see this as you keep zooming in on it, you will always see the same image, smaller and smaller. And what you see on the right is something also that has the same property that's called self-similarity. It's always similar to itself. But this is given by a mathematical equation. It's the Mandelbrot set. Next. Now I show you another fractal, which has the name of a Sierpinski triangle. And this fractal you can build in a very easy manner. So you start on the left with a black triangle. So it is a solid shape in 2 dimensions. And now you draw an inverted triangle in the center. And you cut it out. The white parts I am cutting out. I remain with the 3 smaller triangles similar to the bigger one. Now in each of these smaller triangles, I cut again an inverted triangle. I remain with 9 smaller ones, and I cut again. And we go like this ad infinitum. And then finally, the structure that we are going to get is no longer bidimensional, 2-dimensional, as the one that we started with. That was a plane, a triangle. And it is also not a line that has dimension 1, but it's something that has a dimension in between. Look how beautiful. I am starting from matter, and by cutting, by creating voids, I am going to be able to access a dimension in between. Next slide, please. Fractals are everywhere. They are in nature, all around us. If I look at Romanesco broccoli, and if I look at it in detail, each of these little mountains has the same structure as the bigger mountains. It is self-similar. If I look at the branches of trees in winter, they are bifurcating and ramifying. They are self-similar. They are fractals. Also, the roots of the trees are fractals. Ferns, the leaves, are fractal. Next. Our body is completely fractal. Our circulatory system is fractal. Our lungs are fractal. Every time when I need to exchange, like exchanging carbon monoxide with oxygen, everything I need to exchange is very convenient for nature to get a fractal structure because it favors these processes. But also our neuronal system is fractal. These microtubules are fractal. And there are even dynamical fractals in our body. Our heart beating is fractal. If our heart beating would become completely chaotic, disordered, or completely ordered, we would be severely ill. It is very important that it is in between, not ordered and not disordered, but fractal. Next. These fractals are also very important in science and technology to make antennas or to make, for instance, solar cells, because they meander through the surface and you can absorb lots of energy for the same surface space. Next. And of course, they are very important in art because they appear to our senses as being very beautiful. If you look at this left image, this is in a church in Rome from the 11th century. The name Sierpinski triangle didn't exist yet. Nobody knew what this structure was, this triangle in the center here in the floor. But people already built it because it was beautiful. The structure in the center is from Escher. It's a Dutch artist. And as you go to the boundaries, the same structure is being repeated, smaller and smaller. And the one on the right is from Pollock. You can't see the fractal structure, but it's underneath. And it's probably what makes us classify his paintings as so beautiful, because our eyes recognize what is in nature. Next. So I will now explain to you why fractals have a dimension that's not 1 and not 2, but a number in between. I hope it's some mathematics, but it's not too difficult. I hope you can understand it with me. Let's start on the top part where you see a white line. And now we are scaling this line by a factor 2. That's the 2 that you see here. So now I ask myself, how many of the original white here pieces I can put into this new one? And the answer is 2. Next slide, please. So you see that the number that is here on the right-hand side is 2. And this is like 2 ones to the power 1, because I am in dimension 1. What is appearing in yellow is the dimension that I am. Now come to the bottom. I have a square, which is white. I will scale it by 2 in the horizontal line, and I will scale it by 2 in the vertical line, in the vertical direction. So now I get this pink square, and I ask myself, so the 2 is down here on the right-hand side, and I ask myself, how many of the white square I need to cover the entire surface? And the answer is 4, which means I have to multiply 2 by 2 twice. That's the yellow that's here, because I am in 2 dimensions. Next slide. So now let's take a Sierpinski triangle and let's scale it by 2. Next slide. I am scaling it by 2 here in the horizontal and along this inclined line. And now I ask myself, how many of the original white triangles I get? I am getting only 3, because the inner one had been cut. And 3 is given by 2 to the power 158. Actually, that's where logarithms emerge in mathematics, because the logarithm of 3 divided by the logarithm of 2 gives me the number 158. Okay, so that is how a fractal has a dimension, which is a number. It's not integer, it's between 1 and 2. So they allow us to explore the space between integer dimensions. Next. So my function at the university is to understand the sociology of electrons. I have many electrons in 1 dimension, in 2 dimensions, or in 3 dimensions, and I try to understand how they behave socially. Electrons are very important because they carry currents, they carry electricity. And all our current technology is based on the motion of electrons. That's how you build transistors, to build computers, televisions, telephones, and everything. And now the question that we had is, how would electrons behave in fractal dimensions, in dimensions in between? And you would say, what the frac? Next slide. So to understand that, we used something that had been proposed by Richard Feynman 60 years ago. Richard Feynman gave a talk more than 60 years ago, where he had a very provocative title. He said, there is plenty of room at the bottom. We always want to go to the top, but he was inviting us to go to the bottom. And with this sentence, he was telling us, instead of taking materials and trying to understand them, let's build them in a bottom-up approach, because then we can build what we need with the right properties that are going to be useful for creating the future. Next. And with this, he proposed the so-called quantum simulators. So what you are seeing in this image was the first creation of an electronic quantum simulator that was made in 1993 in California by the group of Don Eigler. And what you are seeing here are these blue waves, which are electrons. So I was telling you that an electron is like a ping pong ball, but at the same time, it's like a wave. And it's very difficult for these small particles to observe their wave nature. But here, what he did, he took a sea of electrons that you cannot obtain on the surface of copper. And then he was positioning each of these spikes here in orange and yellow is one atom of iron. So he positioned them on a very, very small separation of 1 nanometer. 1 nanometer means 0,00080 zeros and then the number 1. So you have 9 decimal cases after the zero of the meter. So it's 10 to minus 9 of the meter. It's very, very tiny. And he could, in a very controlled manner, position all these iron atoms. And then the electrons were confined in this corral. And what you are observing are the electron waves, as the waves in the sea, but now by the electrons on a quantum level. This is the quantum corral. Next. To make the publicity for this work, IBM made the smallest movie ever made. Each white pixel that you are seeing here is one single atom. The movie is called A Boy and His Atom, and you can watch it on YouTube. It's a very nice movie. Next one. So after that, the group of Hari Manoharan decided to make many of these quantum corrals and open the door in between. And then he was patterning all these brown mountains that you are seeing here. Each of these little black spots is a little mountain. And he was positioning them in a triangular manner, forcing the yellow parts, which are the electrons, to go around. And if you position them in a triangular way, the electrons will form a honeycomb, like the bee's nest. And this honeycomb, it's a lattice of a very important material called graphene, which is now being built artificially on a 10 times size of normal graphene. So he created an artificial material, an artificial graphene. And that's the technique that we used, next slide please, to build the first quantum fractal. What you are seeing here was created at University of Utrecht in 2019, and the black parts are the mountains. You see them as dips because we are positioning our tools to see what is in yellow in between, and these are the waves of the electrons. And what we could prove is that these waves can perceive the fact that they are living in dimension 158. That's why it's called a quantum fractal, because the electron waves know they are in dimension, which is a fractal 158. We have proven this. So, but these tools that we are using with electrons were not good to understand how the particles move in a fractal. Next slide, please. And then in 2019, I was visiting Shanghai because I was a fellow of the Shanghai Jiaotong University in the T.D. Lee Institute, and also a member of the Vilcek Quantum Center, which is now in Shanghai. And I became acquainted with the work that was being done by Xiaoyong Shu in the group of Professor Shen Mingjing. There, they were also creating fractals, but now fractals of light. And I immediately started working with them to interpret what they were obtaining. And these fractals in the classical world, they were studied in the 80s. And the problem was seen as like an ant in a labyrinth, how an ant is going to move through the branches of a tree, because this is like a labyrinth for the ant. But now we wanted to solve the problem of a quantum ant in a labyrinth. Next slide. So for this, he's building these structures with waveguides, which are the pink structures are waveguides that can carry light. And the cross-section of these waveguides forms a Sierpinski triangle. Next. And now he's going to inject light on the top to see how the light is propagating. And we are going to measure the physical laws that govern this behavior. And what we have seen is that there is a certain physical law from the moment when you inject, but when the light meets the hole, the physical law changes. And then immediately the photons, which are these particles associated to light, they pick up the fractal dimension. They are seeing just the first hole, but they already know how the entire structure is, because the fractal dimension only emerges if I have the big structure. But after one hole, they already perceive this fractal dimension. It's the parts allowing you to understand the whole. Next. So we found out this law, and we have seen it's very different than how light propagates if you would have a field structure. And we have seen that this propagation law is different from the way how the ant would move in the same structure, because the ant is a classical particle. So next, we then also looked at something called the Sierpinski carpet. This is a square where now I make voids in the square. It has a different fractal dimension, 1.89. Next. And here also we injected light and we confirmed the law that we had observed for the triangle. So it means our discovery is really valid for many different structures. Next. And now comes the very interesting part, which is the connection between fractals and consciousness. What should one thing have to do with the next? So many years ago, Roger Penrose, he won the Nobel Prize 2 years ago for his explanations of black holes. He got together with Stuart Hameroff, who is a medical doctor, an anesthesiologist. And he proposed that the brain should be governed, the consciousness, the process of consciousness in the brain should be governed by quantum laws. But at the time, 35 years ago, people thought that cannot be possible, because usually to see quantum laws, we need to go to very small structures at very low temperatures. But our brain is operating at room temperature. So it was very difficult to imagine how this could happen. And there have been much controversy in the meantime about that, and many experiments and many new things came. Next. So this is the brain and the structure of the neurons. The brain is fractal. So what we claim is, if the brain is fractal, and if we now know how a quantum particle moves in a fractal, we don't need to fight to understand whether the process of the brains are quantum or not. It's enough to measure the processes in the brain and to compare with what we created artificially. If it's the same laws, it's quantum. If it obeys the classical laws, which were already known before, it's classical. So probably we are adding a little contribution to the understanding whether the process of consciousness could be quantum or not. Next, please. So that is then why we believe that our research is bringing us a step forward in the understanding whether consciousness could be explained or not by quantum physics, because we have a very clear prediction, which is quantitative, to answer this issue. But now, people studying the brain, they have to measure and compare to what we found. Next. So I would like to close now, but before closing, I wanted to let you with some inspiring, it's not an experiment, but it is something from YouTube. So Einstein has been telling us that God does not play dice with the universe. But now, after our studies of fractals, I have some doubts. Let me show you why. Next slide. Here is a game that's called the chaos game. So we are going to draw a triangle and choose a random point inside. Now we number the corners of the triangle by 1, 2, 3. and we play dice, we get a number. Every time we get a number, we connect the initial point to this corner and choose the middle point. Play dice again, get another number, connect, and choose the middle point. So we are going to do this many, many times, thousands of times. And this is a random game because I'm playing dice to see to which corner of the triangle I am going to draw this straight line to choose the middle point. But after thousands of iterations, you already see what's coming there. Out of a random construction, a fractal is emerging from the chaos. And fractals are everywhere in nature and in the human body. And it has been generated by playing dice. So maybe God is playing dice with the universe. Please, next slide. Next slide. You can stop the game. Please stop here at the, yes. I can then conclude now by telling you that indeed, I agree with Feynman. There is plenty of room at the bottom, but probably there is even more in a fractal. Next slide, because I would like to acknowledge my collaborators, especially Ingmar Svart, the second one on the top line, who is the head of the experimental lab building the first quantum fractal, Marlu Slot, second from right bottom, who did the experiments for the quantum fractal, and Sander Kempkes, the second from the bottom left, who did the calculations for the quantum fractal, and then Xianming Jin, the professor in Shanghai, who had the lab for the experiments on the dynamics of the quantum light, the photons, and Xiaoyun Zhu, who did the experiments there. I thank you very much for your attention.
Thank you very much, Cristiane. Well, a lot to take in there. And now we're going to kind of hit you from another angle, which is Daoism and ink brush painting. And we're turning to Xiaodong for this. So Xiaodong, when you're ready, please do share your screen and begin. You need to unmute yourself, Xiaodong.
OK， 我现在可以了吗？可以听到了吗？
Yes, OK. Yeah, I will start. So I'm a curator in China. So from 2012 to 2018, in Beijing, I have organized a project. It's called the 8th Day. So I have invited about a lot of the young artists to visit the scientist laboratory, and we invite them for lecture to talk about their research. So in order to continue this practice and research, so I started to think about that how this kind of technology philosopher can be seen in the traditional culture of China. So during the pandemic, I came to Hangzhou. I tried to use the ink brush painting to do the analysis. So first of all, here you can see that this is by Zhu Derun from the Yuan dynasty. It's called chaos. So he said that for the chaos is not square or circle, and also that they have the different shapes. And the shapes, sometimes they disappear. So it's very hard to be measured. So the author's statement I just quoted have shown that the Asian people of China, how they understand about the universe. And also he said, for example, chaos. He said it's something unclear, uncertain, and difficult to describe. So you can see on the picture, besides this, he painted almost a perfect square, circle. And also there is an S-shaped tree and also the rock piles. The combination of the two, actually, it has shown that the most diversified changes. It has also shown that his understanding about qi. So the picture on the here also from the Daoism, the ancient Taoism Bible, I shall say. So it has been used to describe the ancient people's idea about the start of the universe. So it said that the universe started in the cave, and also that the chaos is quite uncertain, and also it's not easy to be distinguished. So the ancient people of China thought that at the beginning of the universe, everything was chaotic. It was chaos. So he used the lines to describe it. Well, Zhang Zai from the Song dynasty of China said that void is qi. So he thought void actually is full of the qi. So it shows that the universe has a very strong vibe. And for void, that actually is all be functioned through qi. And also that when the qi is decentralized, it's about the structure. And also that the void has been used that to describe it. And this, he said the qi is always changing. So, and also that in another philosopher, he thought that the something that is unchanged is the subject. So he thought that the void, the core form of the void is unchanged, but the expression of the void is changing from time to time. So Zhang Zai, in the book I quoted here, that he said that the void is invisible. It is the subject of the qi. And no matter it is concentrated or deconcentrated, that the change is also about all the expression. So this is about the theoretical ideas. So, but if we look at that in the quantum mechanics, David Bohm, I think from the 20th century, he thought, I want to quote, he thought that, and I agree with him, he said, the void here we are calling for actually has a lot of the energy background. It's more like an energy sea, the sea of the energy. The subject or material we know is only a the quantum-based wave. It's just like a small wave in the sea, that you have a lot of the small waves on the top and you get the material. So the material here is referring to the basic particles. So that's why we always say that in the universe, sometimes we have the dark material. So that means it is not unvoid. Well, in the sea of the energy here, the whole material universe shall be seen as a smaller paradigm of the sea of the energy. It is very spontaneously, it is a cyclical, and it's very stable, and it's more like a reflection of the sea of the energy. So Mr. Bohm has explained the Big Bang of the universe, and he thought that in the sea, on the ground of the earth, a lot of the waves have been connected accidentally, and then there is a big wave. So it's just like that it comes from the place of the non-existence and the void of the wave, and it suddenly has been pulsating in the sea of the energy, and that's how our universe has been created in this pulsating expansion. So then it will be continued that into the wave, and it will become into what we call about the expansionary universe. The expansionary universe will include the space inside. So we think the space here we understand is about the order that we can see, and the order is also a very important theory of Mr. Baum. Well, in China, the rule or the order of the qi is about the breathe in and breathe out, inhale and exhale. So the qi going up is yang, and the qi going down is yin. So in China, we have the yin and the yang, and through the inhale and exhale, we have the yin and the yang, and there has been waving and the conglomeration, and then everything, the universe was created. This is a very fundamental universal theory of China. So just like in the quote of the Buddhism in China, we say that it's from the void, there is a tiny, tiny dust. And the tiny, tiny dust is just like a small wave in the sea. And then everything starts with this tiny dust and a tiny wave. So in this state of the void, yin and yang has been in the state of the superposition. So they are both yin and yang, but once that they have been triggered, it's a movement, and then yin and yang will turn around. And also it will be just like for any part of the Mobius band. So the Mobius strip. So it seems that they are contradictory to each other, they are binary, but actually that if you look at it from the holistic view, they are unified, they are two in one. So you can see that in the Chinese ink brush painting, there is about the yin and yang, and this is the very important the tradition that we have in China about the 8 paradigm, the superposition of the energies, and it has been added up to each other. And then when we talk about how the Chinese painting has about that, if you look at the brush stroke, so you look at the trace of the brush stroke, but actually it's a big move. So in the space, it's about the trace left by the whole movement of the brush. So the difference between Chinese painting and Western painting is that it focuses on the circulation, moving around, and the strength, and the weak and strong. It also focuses on the trace of the energy, and also it uses about the requirement of the inertia. So you can see this is the painting that on the side, this is from the Japanese monk, so the Ikuyu Suju. So you can see that on the left side and on the right side, this is about the analysis of each of the stroke, about the strength and the speed. So the movement of the lines actually, or the strokes, they have their own logic. So you can see it's more like the bee dance, that in the middle, that it is the picture drawn by Huang Beihong. So this is the simplest and the maximum wave and movement. And also that for all the animals, you know that in the nature, you always get the simplest way, just like a bee, that to use the simplest dance to get the honey. So that means in the turning and movement, sometimes there will be 180-degree flip. So it flip around. And also, just like the Mobius strip I mentioned, the line and the traces have changed. So it's no longer a two-dimensional one. It will also be flipping over. So it is more than the two-dimensional one. The flip over has created the order of the painting itself. So you can see that this is the energy, the topology circle of the energy, and also combined with the speed. So this is also the picture we have from the yin and yang, and this painter has used to mimic about the void. And also for the paintist, for the painter, you can see that how they release about their idea and make sure that they are on the same frequency of the nature. And this is the brush that the painting is very quick and it's a whole movement. And about how to use that, you can see that they also have the flip around traces. So you can see each of the stroke are related, and also he used the rhythm. So it's not like the one pace. So for the good artists, they will find their natural frequency of their painting, and then the whole frequency can be seen in their painting. So the previous speaker has talked about the fractals. The fractals in the Chinese ink brush painting can be seen. You can see that the fractals is everywhere. So, for example, the quantum mechanics actually have been taking about the particles to be the target of the research, because particles will be the minimum target. But if we take one stroke, each stroke of the Chinese painting as a fractals, so we can look at this video. So this is about that how you can look at the mechanics of the radiums, and if you use the radiums, you can see that the particles, each of them have their own direction, they have their own speed, and it's very interacted.
And this is a natural phenomenon. And this weird thing happens, well, in the Wudai Shuguo. So Dong Yuan made this painting, and we could see the trees are using this specific way of scattering, just like the irradiation of radium. So we could see all these powers and the matrix they formed looks like a matrix. So actually, this is how we can achieve this. So we could see how he's flipping his brush in a very continuous manner. So he achieved a smallest fractal. So there's many changes here involved. So we use a very soft brush to create this different directional javelin. So this is, he was showing his, demonstrate to his students how to paint a rock. So you can see the way he is making this rock is really, he's rotating his brush very freely. So it's completely coherent. So it just dip in the ink for one time. So actually this is one of his slowest movement. So he could be even faster. So on the right, this is something we took in a cave. So we could see the seditation process left this pattern. It's really like the cave of qi. So it's really like before it's a rock, it's liquid. So you can see this is something he painted just randomly. Looks almost exactly like the one on the right, the natural existing rock. So in the sheets of the Book of Changes, Tao include one yin and one yang, and Tao Te Ching said the Tao produced one, one produced two, two produced three, three produced all things leave behind them the obscurity and they embrace the brightness while they're harmonized by the breath of vacancy. So actually, the whole line and the broken line are superimposed and gradually changes and generated into over 4,000 different changes and patterns. It's really like the probability theory just like what Christiane has mentioned. So it is predicting all the possibilities of development of a certain subject. It's really like a higher dimensional prism reflecting the different state of a subject in different time and space. And a painter said the Bagua could include all the possible changes, and they're using the lunar phases to correspond the 12 double alpha and the heavenly stems to everything that is happening in the human world. It's really like a time-space continuum from inner to the outside, and is convoluting. It's just like a topological, cosmological structure. So in terms of particle, a particle's wave function could make it disperse in the entire space in a void. When we measure it, it is collapsed back into the state of a particle. And Bohm mentioned explicit and implicit order to introduce or explain quantum state and the basic structure of the cosmos. So there are two levels, actually. One that is appeared on the biological and physical level. It is the explicate order. There is a deeper level, which is the implicate level. So actually, everything that happens in the time and space has been enfolded in something else. So actually, the implicate order believes that everything is enfolded into everything. It thinks that the cosmos is a whole, and everything, including molecule, atom, elementary particle, are just temporary appearances of the wholeness of this implicate order. What we can see in the 3D world is actually only a projection of a higher dimension. So sometimes, because we cannot understand the wholeness of a higher dimension, so we mistook what we see, all the objects and people, to be individual objects or individualities. So Bohm considers it as a inevitable power, and it could also trigger the mutual transference between the implicit and the explicit orders. So actually, we ourselves are totally immersed in what we see and what we think. And actually, the two, sometimes the entangled particles are actually inseparable. And although they haven't really touched each other, but on a higher dimensional principle, they are inseparable. And Bohm also think that the higher dimensional reality is the shared foundation of the mind and body. They are actually one thing in a higher dimension. So it's saying every section of temporal and spatial structure include the whole structure that has been enfolded within itself. So Bohm has used holograph to give an example. So it's like the whole universe is like a hologram. So every temporal and spatial region is enfolded with the whole order and the whole structure. So let's go back to landscape painting. There are very similar principles. All these trees and rocks, they are part of the entirety, but they include all the elements that is needed. For example, all the density, the layout, all the necessary techniques for landscape painting, and they can be combined randomly, endlessly in this paper, and then generate a very gigantic whole world. And they just follow their own logic to generate and generate. It's just like the cosmos is projected onto different dimensions. there are numerous layers and numerous dimensions, but the original ontology is one. And every part is also very wonderful. And next, about Wu Xing, or the five agents, and about the unity of man and universe. So last time I talked in Goethe Institute, I mainly talked about the five agents or five elements. So this is the inner landscape of the Daoist internal alchemy. And there are many enigma representing how people are exercising, doing internal exercises. And they use landscape to compare the people's body to the landscape. So
Xiaodong, I'm sorry to interrupt here. Just to let you know, we're kind of out of time, which I hate to say because this is amazing. But if you could just begin to wrap up.
好的，我马上说两句，马上结束。好的，这我简单说两句，就是
So I will briefly put it. So to compare the landscape to different parts of the human body, and it's really like the whole system of the five elements. So the gold, the wood, the earth, the water, and the fire, and they can continuously transferring into each other, corresponding to people's body, to the plants, to animals, to everything that is included. So this is something that the Westerners maybe are not familiar with. So last but not least, this is my own painting. I use the five elements to treat it. So, for example, the mountain is like the heart, and the tree is like the liver. So it just corresponds to different parts of our body. So through internal meditation, people can understand the nature and external knowledge. So let's wrap up here. Thank you for listening.
Thank you so much for that really comprehensive overview of Taoism and landscape painting and the relation and drawing those kind of connections to quantum. And I'm going to be so intrigued to hear Cristiane's perspective on this in a bit. But let's now go over to Yue. Yeah, if you could begin as well, that would be amazing.
听得见了吗？听得见了吗？有声音啊？我的好的，我简单介绍一下。
So I will briefly introduce my work. I just listened to the scientist and Miss Fu's presentation. So I think I have felt a lot because my own artistic creation echoes or resonates with many of what they have shared. So I want to share with you some of my feelings or understandings. Next page. Next page.
So
this is called The Gentle Slope. Is one of my long-term projects. So my idea comes from my childhood experience. So when I was a kid, I look at the sun, look at the moon and the stars. I wondered that all these stars and the sun we saw, do they exist in the same time with us simultaneously? So after the acquisition of some basic physical knowledge, we know that suns and stars are located very far away from us, even light years away. So since all these stars exist so far away from us, so the stars we saw, do they belong to us? So for every one of us, the time and space that belongs to us, it's very important for us. It could prove that we exist. But pitifully, after careful examination, through some very simple analysis, we realized that the stars we saw, what we saw is only a past moment. And the moment that belongs to us, well, they always belong to the past. So all these past points are unrelated. Well, I say it's unrelated. Well, I'm only talking about it in a three-dimensional perspective. So I would develop from here. So if we are located so far away from the sun or stars. Next, thank you. So stay here. When we look at the stars, we know it belongs to the past.
Then I started to wonder that when what is around us, what do we see? Is it from the past? So, for example, our discussion now or our communication, are they in the same time and space? So I think that what is interesting is that no matter if you are the subject or object, and also the conversion between the two. So if you look at that generally, maybe we are in the same time and space. But you can see that when the sun is so far away, we have a time difference. And it's the same with the star. They are in the different time and space. So for the people around me, or even that everything we see in the space, they also need to have the time difference. But the time difference can be so minimal that we don't detect it. And we don't know there is a time difference. So I think what is to be sure is that all these objects, all these people, they have the time difference with us. Or I want to say that in the world, everyone is lonely as a person. If you think yourself as a subject, everything you have seen, everything was from the past. And no one is exactly in the same time and space with you. So that's why I said the human beings are very lonely. And then I think one step further. So for example, that the time and space we have seen, if we really want to freeze them in the same space, in the same second or millisecond, and to really to compress that, because time and difference and distance are the simplest way to calculate that, because the smaller the distance is, the time is the more minimal. So when the objects are crashing to each other, when they are touching each other, the space we have seen here, maybe they are under the same space, exactly the same moment of the crashing. So how to represent that they are in the same time and space? So I took some wasted material from the decoration or some abandoned material from other people, and one by one I connect them without anything any bolt to stabilize them, but they are just supporting and touching each other, and there are forces, of course, that to support each other. So this is something what I think is in the same time and space, and it's happening, it's more like a picture, and they are frozen at one time. So, but in reality, what you need is not more like installation or a project. I know that many people will create it that in big scale, but this work of mine, I need to use my hand to feel it. And so also that I mentioned about the conversion, the flipping between the subject and the object. So I was there and I was within this space to create it. So all the objects here, they are not stabilized by any bolts or tools, and they are just simply supporting each other by forces and counter forces, and to be in this moment. So during this process, when making this work, what we can see here is still in the three-dimensional installation. So that means when we jump out of the creation of the art, if you are an audience here, if you come in and observe the artwork, just like Miss Fu mentioned, the Oriental, the Chinese yin and yang, or the brush stroke or the ink brush painting, the way how it is painted, you can also see, just like Cristiane mentioned in her presentation, the fractals. I think in this work, I think all of that can be seen here. But this kind of the immersion or fusion is not done by the result or outcome. What it needs is that at any time, any second, you need to make yourself immersed to experience that. So for example, for each of the wood, each of the iron bought, when it reaches the certain stage, it can have the forces of tons of the force. And if I want to connect it, continue to connect it, because the human, we are very limited. You can only support this that within a few seconds, I need to quickly to find something that to support it, the material to support it. So that's why I said it is a combination of the brain work and also the hard labor. Is like Olympics of your brain and your labor. And what it is finally presented will also be changed by this kind of the flow of the force. And you can see there is an energy like flowing around in the space. So that means, although it is a frozen, it's like here in this space, but all the forces, they have been summarized, added up, and everything contributes and engaged. So this is what really fascinates me, that to have the unity and combination of the space, and there is an energy in between. And it's not what we call it a unity or unification in physics, because you know everything when they are touched between one another, that in the very detailed observation, so even we say that they are supporting each other, but you know that when two objects touch each other, there will be some the electrons or particles or air in the between. So this is what I can feel and shape about this artwork, and including the nature of the material, the wood, the deformation, and also the bending of the steel, and growing of the melons. All of them are impacting about this time and space, or even the corruption, the rotting of the material of the vegetables and the melons. So in this work, there is also something really fascinating, is that all the material, they are very random. The randomness is really out of my expectation. So, for example, if I can put it in other words, it's more like the talk show, very spontaneously. So it seems that people just speak spontaneously, but they also have their own logic. So it's not something that in the physics on the unity, actually it also has its own mentality, ideology. And this is not done by me. This is not summarized by me. But everything was put up together perfectly in the space. No matter what kind of the space you have, in the space, all the objects, all the interrelationship between the two has been defined randomly in this work. So just like Cristiane mentioned in the fractals, the triangle, she mentioned that you find a random point in the triangle and you take a line to the top point and get the middle. So also in Miss Fu's presentation, she talked about the sea of the energy. So you can see that there's something that common here, and this is what is really fascinating about art. So next slide. Can we move to the next slide? Next slide. Yes, next one. So you can see that this material, actually all of them, the relationship between the material are very random. It's not designed or customized. They have been randomly acquired. They seems to be very stable, but they also seem to be very unstable and can be collapsed any second. Or some of the material has been picked up, like the lag from the wasted or the abandoned models. Next one. Yes, next one. This one was in Hushen Gallery. This exhibition that was in Hushen Gallery. So it's more escalated. So that means the space is no longer in the wall anymore. It is a space I define by myself. So it's more like a white box, but it's not stopped or limited by the walls. So within this space, I try to build the unified space, time and space, with all this wasted material. Next one. Next slide. So you can see they are very random. And the gentle slope, this artwork is called gentle slope. In many places, I have localized this product with the space and location. And also, I use some local material, wood, the live products. So each of the artwork, they will be different because they are limited by the local space and also by the available material locally, the time, the moisture. So when making this artwork, they have their uniqueness of that space. It's just like people from each country, from each province, each city are different. And the people from that place, they have their uniqueness. And even for the animals or trees or even materials, you can see that they also have their own uniqueness. Next one. So actually, when I created my own artwork, another important thing is that I tried to use something that is inefficient or unscientific way, but it is also a science-based or science-validated method. I try to analyze, no matter in our daily life, about our feeling, our consciousness. So I try to find these some of the things in between and use the simplest way to express it. So although there is no specific number or very clear algorithm or the logic here, but generally speaking, it is a reflection. I think that a reflection of the creation and the consciousness through my personal experience. Next slide. So finally, I would like to say a little bit that in my art creation, another very important thing which just come into my mind is that this is a very small part of my artwork. And this is also part of my research about the consciousness, one of the clues we have.
So, although I have different artworks, I make different artworks. At the end of the day, when I create, it does not depend on whether it's art or let's call it scientific or human. Well, however you categorize it, I think is really like a individual's existence in the world. It reflects my experience of life and also how I can deal with the environment and the world and how the world is giving us feedbacks. So that's what I have to say. Thank you. Thank you. One last point to make. This is an earlier piece of work. So we know, well, if there are two beams projected in a three-dimensional space, two beams of light, well, especially parallel light, cannot shine into each other. So I want to use a spatial method. Well, so I want two beams of light to illuminate each other through different reflection, so they can enhance each other. So then we have all these fragments of glasses on the floor, so they are reflecting the light. So at the end of the day, it's a very interesting sight. Although the light projected into each other through different reflections, there will be some extra light, but all these extra lights can form some unknown cracks. So when we are walking on the side, and it will keep us on edge, and sometimes we will cover one path of the light, yet you're not very sure from which part did you cover the light? But when you cover one glass, but some other part has become dim. So I was trying to make a project of projecting a beam of light from Shanghai to Beijing. That would be too big, too gigantic. But that was my original thought. But now I am realizing it in a space. So that's it.
Thank you very much, Yu. I hope that's given everyone a sense of kind of this. I think what all the panelists have done is kind of elaborated this space between, among many other things, right? But this kind of indeterminate space, which I think, to me at least, in my basic understanding, allows this sense of holism, this kind of web of intelligence that weaves things together. And yeah, I'd really like to thank each of our speakers for talking this through from their different perspectives. And actually what I would like to do now is give the panelists the opportunity to comment on what they've heard from each other, because we've covered a lot of ground here. And before I say let's go ahead with that, can I just say to the audience who's listening in, this is kind of a thought experiment in a way to weave together these different thoughts, and we're all in it together and learning. So please do add any questions you have to the Q&A or WeChat, no matter how basic they might feel. We're all kind of here to learn. But yes, so now over to the panelists. Really, if you've got any comments you would like to make on what you've just heard from each other, be super interested to hear them.
May I?
Yes.
I am fascinated by all what I have learned today from Fu and Liu. So one thing I noticed that I have a Western perspective. I realize how much more the East art is concerned by time. So how much time enters in a very harmonic manner. We know in physics the notion of space-time, but when I look at the ancient paintings that Fu was showing us, how much the movement in time is being represented and viewed by the population who is watching that. We don't have this concept so strongly. And now when I look at the art by Liu, I see the same. I see how much he's capturing time and the fragility of the entire structure. While he's putting together, I can see the fragility of life. I can feel it. I can see how space is being filled and let empty in the same way of the fractals, integrating disorder in a disordered manner, but bringing us a full feeling of connectivity and understanding. So it was absolutely fascinating. And when you use light to make cracks, when you say I'm using light to make cracks, it's in the way how I'm taking out the holes in the Sierpinski triangle. So I completely feel all this, how the silence is giving the rhythm to the music, and how the emptiness is giving the meaning to the matter. It was absolutely fascinating. Thank you.
Is there anything, Yue or Xiaodong, you'd like to add there?
我说两句，就是
So I want to say, Christians, you mentioned what you were researching, especially fractal. Well, I'm very interested in this regard. So when you mentioned the Sierpinski triangle, well, I was using a very simplistic way. Well, I cannot share with you the video of another piece of work. Several years ago, I made a work called Volume, and I used a basic shape from the corner, and we can expand it into a triangle that is even larger than the pyramid in a plaza. So I think no matter Eastern or Western cognition or research, at the end of the day, our fundamental trouble lies in the visual perception or visual cognition need to be concluded in some point. For example, in our life, we cannot have a conclusion. To put it in a more simplistic way, well, if you are getting married or giving birth to a child, you cannot be sure what will be the future of your wife or what will be the future of your children. We can only project, we can only guess, but we always come into the world and we know sooner or later we will die, but we don't know when. Even if we know this person is very strong, very healthy, he or she can live for a long time, and we know one person is very intelligent and he can achieve a certain higher state of achievement, but we are not sure. We want to use a two-dimensional way to conclude, to have a conclusion. So I think there might be a way in the world in which we can reconcile with each other. So this is my answer or comment. Thank you. Christine's theory of fractal, I think in Chinese landscape painting is very important. I think the Oriental painting's structure, as I mentioned some details, and it can be expanded into the whole canvas or whole picture. And in the West, after modernism and through the Logos, especially the abstract expressionism, they're using the geometric shapes to shape it. But in the East, our paintings actually used fractals, just like what I showed you. The painter, they can use a part of it to represent the whole, and all these fractals are superposed together, and they can include all the different changes and possibilities and leave trails on the picture and then expand it to the whole picture. So it is following a different logic than the Western abstract expressionism. And nowadays in the world, people are thinking the Chinese ink wash paintings are painting abstract paintings, but no, actually we're using fractals. And actually due to time concerns, maybe I didn't say it very clearly. And also the Chinese painting is the best way to demonstrate fractal. For example, the branching of trees, and the Chinese painters are very good at doing this, and also the texture of rocks or the structure of mountains. At the end of the day, they want to form a whole universe, just like the structure of a universe. They're painting a complete universe. So this is the difference between the Chinese landscape and the Western landscape. So we want to include in a landscape all the logics, all the possibilities in the landscape, Chinese landscape painting. So this is how the logic of formation looks similar between the West and the East paintings. For example, we have all the geometric components, but the logics are really different. So I've always been doing research into this. So there's a huge gap between the East and West. And actually, the quantum physics, I think, is very useful or helpful when it comes to understanding Chinese painting. I think standing on the shoulders of the research of scientists, we can better conceptualize the ancient Chinese artists' way of understanding and creating art. So maybe use a different knowledge structure. It's still open and has many possibilities and go into uncharted areas. That's all I have to say now.
Great, thank you. We have one question in the chat, which I might just bring in now, and then I'm going to ask a question of you all, or slightly different questions for each of you, actually, but around some kind of themes. But in the chat, someone has written, and this I think is for you, Cristiane, you introduced some sculptures created by a German physician. I'm trying to think which one it was now. I want to know, during his creation process, does he also need to apply the same equations? I'm not exactly sure, but maybe you can. I don't know if that makes sense to you.
I'm not sure I understood. Let me try to read it, because in the first section, yes, a physicist, yes. No, I don't think he is applying equations, but what he's trying, so by using structures which are two-dimensional, to build a three-dimensional sculpture, and using time and the space in the sense that you can move around it, you will acquire the different perspectives. There will be some when you will just see the very tiny parts of these planes, and then you don't see anything, it's empty. And others, you will take an angle when your sculpture appears as solid. Probably, I don't think he used the equations for it, but I am not fully sure about that. There is also a church in Belgium which is built along the same principles. It's combining the dimensionality and the spacing between to capture simultaneously the emptiness and the solidity of the objects.
Thank you, Cristiane. So, okay, I'm gonna kind of get us to dive a little bit deeper into the dynamics of order and disorder and the spaces between these states. And actually, Cristiane, I'd like to ask another question of you to start this going. So in your presentation, Cristiane, you seem to say that fractals offer this kind of middle ground between order and disorder. So, for example, if a person's heartbeat is too ordered or too disordered, both are kind of life-threatening. And so it's important that it's got this kind of fractal structure to the heartbeat. And I guess I'm wondering, could you tell us a little bit more about why the fractal is important in this scenario, and bearing in mind this question of this interplay between the cohesion and destruction in quantum states?
Yes. So usually classical particles, if you have a car moving from Shanghai to Beijing, okay? So you have a road and you can absolutely predict which road this car will take. It's the shortest road between 2 points. And you can always know its speed and its position at the same time. For a quantum particle, you cannot. If you know precisely where the quantum particle is, you don't know its velocity. If you know precisely its velocity, you don't know where it is. So this is the uncertainty principle by Heisenberg. You can know more or less where it is and more or less its velocity, right? But there is one beautiful thing about the quantum particles, is that while they move, they explore the entire space. They don't move. If you are going from here to here, they are not moving through a line as the car would. They go through all the possible infinitely many trajectories that are connecting A to B. And this is very counterintuitive to us. So that's why in the fractal, when the quantum particle is moving, it has met just the first hole, but it already knows about the entire structure. Although it has explored only a little part of it, it has the full understanding of the complete fractal. And I think that's why it's very important. it is a very natural example how the little part contains the knowledge of the totality. A piece of hair has our DNA, right? It contains the entire information. It's a very tiny part, but everything is encoded there. And the fractal is a very natural way how this happens. And it's visual. You can see because it's reproducing itself. And since nature and human bodies are so fractal, it's very important to study them because science has been letting them aside for too long.
And I wonder, Yue or Xiaodong, would you like to comment on that from what you've been looking at in your work or in your presentations?
对，实际分型，我觉得那个就如果在中国画里面来说的话，那么它一个
Yes, I think that for the fractals, actually, it's about the yin and yang. Actually, we can see if we return that into, it's more like the Mobius strip. So actually, that this is the basic fractals, and also that in the yin and yang, and also that is a unity. At the same time, that it is also like circulating. It also in infinite and definite. So actually, that I am very interested in this theory and analysis, and I found it very fascinating and very interesting. So currently, in the current painting of China, so for example, when the painter that your brush and stroke, it's just like the traces of the movement of the animals. It will find the most efficient way from getting the A point to B point. So just like the Mobius strip, it is the basic shape they have. So we always tried that the essentials of the universe and also the basic of the basic and where it originates. So maybe there are many different kind of the interpretation and expansion of that. But I think the structure of the universe, whether it is a high dimensional image reflected in the two-dimensional, for example, in ancient China, in the pictures and paintings, actually, this is what you can see, that it's more like a reflection of the multiple dimensions. And that is the yin and yang we say. And also the one I have quoted, Mr. Bohm, the physicist, he has also used that. And also the Li Zhengdao, that he has made a building in Shanghai, and also the shape of the building is very similar to the yin and yang. So I think that all these are closely related to the quantum mechanics. And also based on the practice, just like I mentioned, the one stroke and the brush stroke, and use it that to simulate the rules of the universe. I think that for many, many years ago, that, for example, like in the ancient times of China, about thousands of the years ago, that the Asian people have already felt that. So that's why I think it's very interesting. And also, I think this kind of the ideas and also that the ideology and cognitive patterns are very interesting. So for example, in our consciousness, whether we can feel that the high dimensional rules, and when they realize that, and also they express it in the very practical ways. So these are also something very interesting for study. I think for the quantum mechanics, it's just open the door, open a window for us to understand the nature of the universe or the origin of the universe. So I think the discussion here today is very important, and I'm very happy to hear. And also, I'm very interested that in the research. I'm very happy to see that many of you are very interested in that, do the research, because I think for me, it's a very fundamental or very basic way. It's more than the image or the topology. And also it is based on the original point of the physics and to reconstruct, to explore the truth of the universe. So that's why I think in certain sense that the artists and the scientists are the same. We are doing the same job. We explore and based on our experience, try to find out the truth and what is the real and beautiful. Thank you much.
Thank you. Yeah, and I also found it just so interesting thinking about Yui's installations and the energy and movement and the way in which the materials lean precariously against each other, and they're all, you know, exerting a force on each other, and that is what's kind of holding them in place. And then thinking about that in relation to the brushstroke of the landscape art painting, or is really, really, I think, interesting in this context. Yue, I wondered also if you might touch on your volumes exhibition, which you mentioned briefly, and I know Cristiane's interested in this, in terms of this kind of question of the way in which fractals exist between dimensions. And I just wonder if you could say a little bit more about how you were exploring dimensions within the installations you were creating then. I think you mentioned, I don't know if you've got any images that you could screen share with us, no worries if not, but yeah, if you've got any comment on that, be really interested to hear it. And then Cristiane, you might want to respond to that.
不好意思，我打断一下，前面说到的体积应该可能问的是我的作品吧？
Yes, the volume actually is my work, right? Yes. Okay. Yeah, the volume. Yes. Okay, I will try to answer the question. So volume, actually, this piece of work, actually, it also has what we say that in China, in the ancient philosophy, we say that 1 to 2, 2 to 4, and 4 to everything. And so these are some very interesting philosophy in the painting. But for the volume, for this piece of work, actually, that you can see that on the internet. And the way I have created it is very Western. It is a very science-based. It is a calculation, and also just like the ancient Egyptian to build the pyramid. So this is how I try to create my work. That is to engage and to use the labor to create it. So all the work I have created, I don't want to distinguish. When I create it, I don't want to distinguish whether it's from the East or West, or I don't want to think about whether it's belonging to the Daoism or from the Western artistic way or scientific way. I'm more interested in which way I can present the ideas, or to find that about the in-between, the space in between, or should be something that is beautiful and leave the clues for the audience to find out. So that means I try to find out what has been neglected. And also, when I created the artwork of the volumes, actually, it's just like for the children, when they do the painting, they will start from the simplest way to draw the line, the cubic, and also the very small cubic, like 10 to 12 centimeters and cubic, and then you place it at the corner of the wall, and you use the cement, you use all the other kind of the materials. So to try to lock it here, and then when you take this cubic out, actually you get something that is negative. And then when you put all of that in the corner of the walls. So finally, that at last, what you can get is a huge one. It can be like a 10 meters or 20 meters of the volumes, or what I say, the cubic. But there is also a philosophy I have. And also there is something contradictory to each other, because with the human engagement, so it's not as simple as the science, like 1 + 1 = 2 and 2 - 1 = 1. It is not something that you can deduct, or you can try to validate it or counter-validate it. Because every time you create of the art, you have the human part inside. So it's not like the science that you can exactly reverse it and get what you got. So this is how we say is the feeling of the artist. And also the stroke of the painting. And when this something has been repeated to a huge cubic, like 10 meters or 20 meters, and when you try to reverse everything back, so there is always a deviation in between. And then that is what we call, like, when you try to counter-validate that, then it is something that we cannot do that. So for example, if you get something from the ancient tomb under the ground, you can only get it very visually, but you couldn't validate, because nothing can be perfectly that the counter-validated back. So that is what we call about the reliability of this perception, because in this time and certain time and space, you couldn't have something absolute, or something absolutely reliable, or something that is absolutely deductible. So this is something I try to express in the volume.
Thank you. And while I just ask if Cristiane has got a comment, I'm going to just, and please do carry on begin commenting, Cristiane, but I'm just going to quickly share my screen, because I've just brought up some images of that work. And I'm also just going to mention to the audience, we've got a couple of questions in the chat, which we'll move to after this, maybe about 10 more minutes, as we started late, and then we'll wrap up. So we'll probably be ending about 7:15 Chinese time, and about 1:15 UK time. Right, I'll share my screen and let Cristiane respond there. But I'm going to leave, you can hopefully see some images here.
Yes, so fascinating the way how Liu was saying that he uses what was neglected to create something new that hopefully is going to answer our most fundamental questions and the quest for understanding of ourselves, of our universe. And I think he's absolutely achieving it. It's my feeling when I look at his artwork. If I'm allowed, there was something else that he said before that I would also like to comment. So first, there is the issue that 1 + 1 = 2. In physics, we are nowadays very much concerned how 1 + 1 is not 2. And this means emergent behavior. And this appears in what we call complex systems. For instance, birds, when they are flying, you have a bunch of birds forming a certain structure. It's not simply the sum of 10 birds. It's much more than that, because they together form structures. And this we call it emergent phenomena in physics. And it's appearing all the time, and we are very much concerned with that. So we use mathematics to describe our understanding of the universe, but very often it goes beyond the usual mathematics concepts in what involves complex phenomena. But I wanted to comment on something that he said before, that when he's trying to position things in time and in space, you cannot have two objects occupying the same space at the same time. So I'd like to tell you some concepts in physics that are very interesting. We have two types of particles in our universe. Some are very lonely particles, and they are called fermions because of Enrico Fermi. This is the Italian physicist. Fermi discovered them. And then we have other kinds of particles which are called bosons. They are very social, and they carry this name because of Bose. This was an Indian physicist who discovered them. These are the only particles we have, the lonely and the social. The question is that the lonely, they cannot occupy, electrons are fermions. They cannot occupy the same state. But the bosons, they can. Okay? And what's very interesting is that a single electron, you can't put two in the same state. But if now they form a couple, mediated by other interactions, they can form a couple and they become a boson. And then they can go into the same state. That is a very curious phenomenon in physics that could be a source of inspiration for artists in the understand how we can become a whole and go all into the same state. There are phenomena which are very much studied also by many important physicists in China, which is called Bose-Einstein condensation. And this is when all these particles go into the same quantum state. And we can even visualize that macroscopically. So this is something very fascinating where, again, physics is meeting the ideas of Liu. And another thing I would like also to comment on what Fu was saying about projections. So actually, it also exists, and it's something I'm studying with my group very much, something called quasi-crystals. So quasi-crystals, if you start from a structure in higher dimension, which is perfectly ordered and symmetric, when you project in a lower dimension, like if you start with a cube, which is very partitioned, and now you project it in 2 dimensions, the structure you will get is not ordered. But there are certain measurements you can do where you see some order in a structure that at first glance appeared disordered. This is because it kept the order of the higher dimension that was there and we cannot see. And these structures, for instance, if you put a one-dimensional line on which you put sites following a Fibonacci word, this is a quasi-crystal that would come from a projection of grid. If you take a line with an incommensurate slope, these structures are going to have fractals in energy. So actually, the fractality and the projection from higher dimensions of structures which are ordered into disordered, they are all connected. And that's something that we are currently studying very much in physics also. So we can see that physics is meeting art in many different ways through different paths. That's what I wanted to say.
Thank you. And I would really like to carry on that and invite everyone to comment, but I think we need to address some questions that have been coming through in the chat. So I'm going to read a few of those out. So the first one, particularly addressed to you, Xiaodong, I'm reading a translation here. Having listened to your lecture with great interest, I feel that you have a deep understanding of the relationship between ancient Chinese people as independent beings thinking about the universe. As an artist, how do you use or break away from the current system of knowledge to consider the world as an independent being? And you can actually see the Chinese as well, I think, in the Q&A, if in case that's a more accurate representation of the meaning of the question.
那个首先我非常感谢那个克里斯Tina 刚才
Thank you, Christine, for your comment about the quasi crystal. I will pay attention to your research and I'll wait for your results, and I can learn more about the truth of the universe, about what it is. The ancient Chinese way, I think, well, in reality, they have an entire mind-body technique. Well, we humans, actually, we humans are projections from a higher dimension. So actually, through understanding ourselves, we can go back, well, in the Chinese way, in the Chinese traditional way, we can enter a very calm state. You can release everything in your mind. It's really like, well, a swarm of ants. So one ant is not intelligent, but a whole group of ants can be very intelligent. They can protect each other and create many things. But if we enter into this calm state, well, this is what I'm guessing, maybe the quantum entanglement can be interacting with other particles in the universe, then you can surpass an individual's life. So go beyond what we understand. So this is what the traditional Chinese, the ancient Chinese are using to build our traditional Chinese medicine and Chinese painting system. So this is the model that the traditional Chinese culture is based on. And using this mind-body technique, maybe the Buddhist and Daoist are also using it, and even the Chinese are using this way to break away from ourselves so that we can be united. The humans can be united with the universe, so that the humans are not opposed to the nature, but are in one with nature. And that's how we understand this world.
Thank you. And I'm having to rush through these a little bit because of time. I'm going to just split to a question that's in the live channel, which is maybe more of a provocative, challenging question, saying, is it really necessary to place quantum physics and Chinese ink painting brushwork together and make such comparison? For me, this logic is rather far-fetched. In this case, all humanistic or artistic situations can be explained with quantum physics, can't it? Any thoughts on that? Yeah.
For me, quantum physics is art.
There you go.
We are much closer to all what we are discussing here than to the concept of something extremely precise, because it's probabilistic, it's not deterministic. So it goes very much to what is unknown. It contradicts our own perception of the classical reality around us. It is a very complex concept. So I think that's what we're doing.
Yes, exactly. And I think art is so often working with states of indeterminacy, and I would agree that there is a connection there then with what the Chinese ink brush painting is doing. And I wonder, yeah, Xiaodong, would you like to really briefly, because we are kind of out of time now, add anything?
对，肯定我是认为
，Well, I was studying the relationship between art and technology and science. So actually, through a long journey, I focus on Chinese traditional painting. So there are many people connecting traditional Chinese medicine to the technology. So actually, this is a way the Chinese make sense of the world. The Chinese signs are different from the Western way of understanding based on geography, geometry, and experiments and other things. So in fact, I think in many areas there are many things have been lost. So actually now we are using this materialism Marxist understanding. So our understanding of the ancient way of ancient worldview has been, many things have been lost. So we have to go back to understanding what they used to think about, what was their traditional way. So I don't think it's far-fetched.
And any Yue, any final comment from you before I bring the conversation to a close?
好的，我稍微说两句。前面听了
So after listening to Fu and Christian's talks, I find two things. One is that scientists are using a scientist's way to perceive the artist's way of understanding, and the artists want to expand art, to endow it with more dimensions, and to describe the quality of art itself. But I think it's really like it's like between a deer and a rhinoceros. They are drinking and running together. It looks as if they're unrelated. They look different, and they're two different animals. But from a bigger perspective, a grander perspective, they are the same. They both exist in the universe, and to perceive the world and to understand the world. So what Fu has said about the Eastern way of understanding the world, I'm very interested.
So my personal feeling is that actually the narrative, or with the uncertainties with the quantum mechanics, actually they are the same. It's just like the deer I mentioned. Can you imagine that a rhino that is eating the grass, and also how it will impact its body? So from the phenomenon, we can think about another related state. But if we, for example, if we take the figure of the deer, the horn of the deer, if you combine, these are very different from the rhino. But if you analyze the two of them, just like Cristiane mentioned, it's more like the very old school physicist to talk about that. And also it will be a kind of the trap of the questions. So this kind of the trapped questions for art or for science, none of them contribute a lot. Because I think if you look at the art history, nowadays, what is more important is not like to summarize the literature of the art or the evolution of the art. I think in the past 100 years, art has changed has changed a lot, and sometimes it's very boring and it's dumb. And people say that, oh, this kind of the style has been popular like decades ago or others. But actually, from the other perspective, I think for the artists, this is a big challenge. For the artists, we need to be more confident to face and present the art it is. So no matter if you are the ancient people or nowadays, everyone faces from the birth to death. And we shouldn't say that we are the youngest or we are the best generation. We live the best life in the world. And also, I think for everyone from the day of the birth to the death, I think that as long as it's unique to individuals, that will be enough. And also, is how it can be more measured from a broader sense to find out the state of your existence in the world. I think that is very important for the artists.
Thank you. And thank you, everyone. I think, obviously this is a conversation that could expand in so many directions. And I hope it's something, maybe the recording will be something that people can return back to and kind of use as a kind of springboard to think down different kind of trajectories for some of the things that have been covered in the presentation and that we've heard today, and the snippets of conversation that we've had. I certainly had a ton more questions, but yeah, we're wrapping it up for now. And Robin, I don't know if there's anything you want to add. Please do appear if you're there, if you would like. But on my part, I'd just like to kind of thank again the panelists for your brilliant insights and presentations and taking the time to talk us through and being open to connecting these different forms of knowledge and thinking and seeing and exploring the similarities across them all in these overarching question of quantum nature, holism, and the space between. And I'd really like to thank the audience for sticking with us and for your questions. I'm sorry we didn't get to answer one of them, I think. And yeah, and thank you to the Goethe Institute. Yeah, and over to you, Robin, if there's anything you'd like to add.
Well, there's nothing much to add. I mean, I feel quite illuminated and I learned a lot about the interplay of chaos and order in nature and holistic perspective. And I would very, very much like to thank Cristiane Morais Smith, Liu Yue, and for Xiaodong, as well as you, Lucy, for leading us through this very complex process. And I think, of course, we have to continue. But first, we need to digest all those fabulous ideas and dimensions. And thank you to the audience, to everyone, and have a very nice weekend. Thank you so much.
Thank you, everyone. And thank you to the interpreters too for an amazing job.